Welcome to 8.4. Our lesson essential question is, how can I use cosine and inverse cosine to solve for unknown sides and angles? So this is the last one that we're going to get to. So we have so opposite, sine is opposite of prime. Cosine is a over h, that's adjacent over hypotenuse. And the last one, toe, that was our first one, tangent is opposite over adjacent. So let's learn about cosine being opposite over hypotenuse and how I can use it. So, cosine ratio of an acute angle in a right triangle. It seems like that's been key. It's always been acute angles in a right triangle. I haven't done any math where this was my reference angle. It's always been here or here. That is true. We're never going to stand here. So is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. So if I'm here, hypotenuse is hypotenuse, this is my adjacent. If I'm here, this is my adjacent. So as long as I have hypotenuse, now I can solve for either side. So use the right triangle shown to calculate the values of cosine of 30, 45, and 65. So I'm going to be right here. Cosine is adjacent over hypotenuse. So the cosine of 30 equals 4 square root of 3, that's my adjacent, over 8, reduced to square root of 3 over 2. The cosine of 45 degrees, 8 is my adjacent, this is my hypotenuse of 8 square root of 2, so that's going to be 8 over 8 square root of 2, and that's going to reduce to 1 over square root of 2. I want you to do cosine of 60 degrees. So pause the video, try it, and we'll come back. Okay, so this angle's 30, that means this one has to be 60. So now my reference angle, I'm right here. My adjacent side is the 4. So it's going to be 4 over hypotenuse, is still hypotenuse, 4 over 8, reduces to 1/2. Hopefully you got that one. So we have a guy wire that is 600 feet long and forms a 55 degree angle with the ground. So I've got something very tall. We'll say this is a building, whatever. And the guy wire is 600 feet. I want to know the number of feet from the mast's base to where it attaches the ground. That's this one. So if I'm standing here, this is my hypotenuse. It's across from the right angle. This is my opposite and adjacent. And this is the cosine unit, so we're going to use cosine. So the cosine of 55 equals adjacent unknown number over 600. Multiply by 600, so that cancels out. 600 times cosine of 55. I'm going to use my calculator. I'm going to check that it is in fact in degrees. Many times, with this digital one, whenever I open it up, it goes back to degrees. But you might have a classmate that might be doing math in degrees or in radians. And if I did this in radians, it'd be wrong. So the numbers were 600 times cosine of 55, 600 times the cosine of 55 gives me 344.1. So this distance, the distance I asked for, is 344.1 feet. I want you to pause the video, and you're going to, not right now, you're going to be up here now. Calculate this degree angle, and then use cosine to figure out how tall the post is. Okay, welcome back. So if I'm up here, my adjacent is now this side height, and I need to know my unknown angle here. Well, 90 minus 55 is 35 degrees, so I'm going to have the cosine of 35 degrees equaling adjacent unknown angle, A, over 600. Once again, multiply by 600. So in my calculator it goes 600 cosine of 35. Go to my calculator. 600 times the cosine of 35. And I get 490.5 feet. As with all triangles, the hypotenuse has to be the longest side, and since 55 is bigger than 35, this side should be the second longest side. If I got a number that wasn't bigger than 344, I did something wrong. If I got a number bigger than 600, I did something wrong. Moving on, we are now learning about inverse cosine. And as with inverse tangent and inverse sine, inverse cosine is for solving for unknown angles. So the inverse cosine or arc cosine of x is the measure of an acute angle whose cosine is x. When you know the length of any two sides of a right triangle, it is possible to compute the measure of either acute angle by using the inverse cosine or cosine to the -1 button on a graphic calculator. In right triangle ABC, when cosine of A equals x, then the inverse cosine of x would equal the measure of angle A. So, how to do this? Well, I'm going to inverse cosine both sides. So inverse cosine of 2 over 7. Go to my calculator. Inverse cosine, second cosine button, 2 over 7 equals 73.4 degrees. Let's try one. I want to calculate the measure of angle B. If I'm standing here, this is my opposite, this is my hypotenuse, this is my adjacent. Well, which trigonometric function is adjacent at hypotenuse? That's going to be cosine. The cosine of unknown angle B equals adjacent over hypotenuse. So the cosine of angle B equals 16 over 18. I'm then going to inverse cosine both sides. That's the inverse of cosine. Undoing cosine. So in my calculator, I go inverse cosine of 16 over 18. Second cosine button, 16 divided by 18. And I get 22.3 degrees. This is going to be one for you guys. Pictures are already drawn. We got the cables at 95 feet. The distance from where you're standing to the post is at 80 feet. You want to find out what the angle is that you're standing at. So pause the video and try it. If I'm standing here, this is hypotenuse, this is adjacent, so it's going to be the cosine of unknown angle x equals 80 over 95. Inverse cosine both sides. Those cancel, so x equals inverse cosine of 80 over 95. I'm going to go to my calculator. Inverse cosine of 80 divided by 95, and I get 32.6 degrees. If for some reason you inverse cosigned 95 over 80, you get this error. I'm going to quit. Why did I get that error? Well, riddle me this. Make a right triangle drawn to scale where the hypotenuse is 80. Okay, I can do that. But one of the legs is 95. Well, that's impossible. That triangle is sad. I can't have the hypotenuse being shorter than a leg. So this triangle doesn't exist, and the calculator gave you that domain issue as a, hey, rather than saying it doesn't exist, it can't happen. Like, they're saying it doesn't work. So if you get that, you probably put the numbers in upside down. Okay, so for the check-in, I want you to do the talk on page 586. So you're going to give this table, and you're going to look at what function I would use if I was trying to find an angle and knowing these two sides. So for the first one, if I have the hypotenuse and the opposite side, I need to know this. Well, opposite and hypotenuse, that's tangent. Okay, and then I want the solution requirement is to tell me the measurement of the reference angle. Well, solving for an angle would be the inverse, so that would be inverse sine. So go and finish this table, and it's good thinking. Once now we're going with this one, we've done all three of these, your problems will be a mixture of all of them. You're going to have to say, oh, what do I have? What I have is adjacent and hypotenuse. That means I have to do cosine. And then am I solving for a side? Well, then I use regular sine. If I'm solving, or no, regular cosine. Or if I'm using solving for an angle, I would use inverse cosine. So, and then for the check-in, how can I use cosine and inverse cosine to solve for unknown sides and angles? Yeah, make sure you're doing homework with the intent to understand this.